we are going to graph these now. So we need to come up with a table of values. Usually -2, -1, 0, 1, 2 is sufficient. So if I put -2 in for x, what does that become?
4.
Yeah, 4. If I put -1 in there, what does that become? 2. 1. 1/2. 1/4. Yes? Okay. Does everybody remember the base graph of 2 to the power x? How does the base graph look for 2 to the power x before I graph that? Yeah. Yeah, so just make sure you know a few of the points just so that you have the base graph. So that's the half, that's the 2. If you want, you could do 2, 4. I know some people have asked, why do I always use 2 to the power x? Do you think you know why? Well, no, but any base when it's 0 would be 1. But why would I choose a base of 2? It's nice, yeah, it's a low enough number when I start squaring or cubing it, it's still a reasonable number. Versus something like a base of 10, I would be into the hundreds or thousands by the time I start doing more. So this is my base graph, y equals 2 to the power x. So let's compare it, and that's what we learned yesterday. Let's compare it to what we have here. Now, before I graph this, does anybody think they know by just our pure transformations from the first unit, a reflection over the y-axis? Very good. Because you see it's a negative x. Okay, so let's just graph it just to solidify what we just said about the reflection over the y-axis. So -2 is 4, -1 is 2, 0 is 1, 1 is a half, 2 is a quarter. So does everybody see this is what we did? We did. So we're just adding some more things here. So this is y equals 2 to the power -x. What about 1/2 to the power x? Let's I'll use a different color here. It would be the same. That's what we did yesterday for sure, is recognizing that 1/2 is 2 to the power -1, so that would be exactly the same thing as a. But even if you forgot, let's just fill it in the table so you can see that they are in fact the same. So if I put -2 in here, how do you evaluate 1/2 to the power -2? Yeah, you flip it so it becomes 2 over 1, and then it becomes to the positive exponent. So does everybody see I get 4? And I will in fact get exactly the same thing as a. So this and y equals 1/2 in brackets to the power x is the same exact thing. So can anybody guess what's going to happen with c? Yeah, reflection over the x-axis. Okay, and just to verify, we'll do some coordinates here. So we'll do -2, -1, 0, 1, 2. Again, I'll plug in -2. And just so you guys are aware, -2 to the power 2 is not the same thing as -2 in brackets to the power 2. Does everybody understand that that is not the same thing? One is a positive answer, one is a negative answer. Okay? So you got to look at this as bed mass. What do you do first? You do exponents first. That means you would square this first. Then essentially this is like a -1 times the 4, right? Whereas this represents -2 times -2. They're not the same thing. Okay, so that's the only places that I see students get tripped up, is the fact that they assume that the exponent is with the negative, and it is not. This negative is an after fact that does a reflection. So if I put -2 in for x, I get 2 to the power -2, which we already evaluated was 1/4, and then I stick a negative in there. Do you see that? -1 goes in there. 2 to the power -1 is 1/2. Then I stick a negative in there. 0 goes in. 2 to the power 0 is 1, then I stick a negative in there. 1 goes in, to the power 1 is 2, and then I stick a negative in there, and then of course I get negative 4. So if I were to graph that, I get negative 2, negative a quarter, negative 1, negative a half, 0, negative 1, 1, negative 2. Do you see what's happening here? It is a reflection of the base graph over the x-axis, just like we predicted. Okay, so any questions there? Okay, we're going to move on and have many transformations now. So, do you remember what this A does here? Yeah, it's a vertical stretch or compression. What does the B do? It's a horizontal stretch or compression. What does the H do? Shift left. Yeah, it's a translation left or right. And what does the K do? Yeah, it's translation up or down. So just like the last unit, the B has to be factored out in order to see it properly, okay? So watch for that. Okay, can anybody describe what's happening in A here? Yeah, compared to the base graph, this is a shift down 1. So we're going to do the base graph first, and then we're going to translate the three points down. So I'm going to do, say, 2 points here and here. Remember, we have to put a scale and our XY axis labeled. Again, we'll do a quick sketch here. So that's a half, 1, and 2. We know it looks like this. Do you see how I'm getting this so fast? Yes? Okay, so there's my 3 points I'm going to translate. Yes? So we're going to shift it all down. So this becomes here. This becomes here. And this becomes here. Where's my new asymptote, by the way? Yeah, everything gets shifted down 1. Do you see that? So I need to probably put that there. Yeah, so it looks like this. Yes? Y equals to the power x minus 1. Okay, what is my domain? Yeah, negative to infinity. What's my range? This is of the transformed graph, of course. What's my range? No. Try again. Yeah, because it got shifted down, it's negative 1 to infinity. Remember, it's not including negative 1. Okay, x-intercept. It's not 0. Oh, yeah, it is 0. It is 0, and because x-intercept is 0, then your y-intercept is 0 as well. Okay, so we're going to draw the base graph again, right? This time, because the base is 1/2, let's just draw it as a 1/2 graph. Do you remember how a 1/2 would look? Huh? Yeah, so the 1/2 base graph, remember our base graphs can be any base, just as long as you know what it looks like, right? So at negative 1, it's 2. At positive 1, it's a half. So it looks like that. So that is y equals bracket 1/2 to the power x. Remember, you need brackets for these, right? Because the exponent is to the whole entire fraction. Okay, who would like to tell me what kind of transformation occurred here? A description of it. Did it go left or right? No, it's not going left. It's going right. Yes, it's going right 1. Yeah. So this point gets shifted over 1. Sorry, I'm going in the wrong direction after all that, aren't I? Try that again. This point right here is going right 1, and right 1. Yes? Is everybody good with that? Okay, so what's my domain? Yeah, it's still the same. What's my range? Yeah, still the same, 0 to infinity. What's my x-intercept? There is none. So make sure you put none and not 0 or leave it blank. If you leave something blank, that means you don't know what the answer is. If there is none, put none. Y-intercept? It's 2 this time. So right now we can tell what the x and the y-intercepts are graphically. Eventually we're going to get to a point where we're going to solve them algebraically. Okay, next one. Who can describe what's happening here? Vertical. Okay, vertical stretch. Factor. 3 times the amount. What else happened? A reflection over. No, it's an x, like you said, x-axis. It's affecting the y, right? So it's a reflection over the x-axis. Okay, so our base graph is 2 to the power x. If you want, you can fill this in. I'm hoping that by now you're pretty good at your transformations, but I'll fill it in just to verify to yourself that it is, in fact, the same. So, of course, we know that it's -1 as 1/2, 1, 2, and 4. Like I said, you probably only need 3 points to get the gist of the graph. So here is 1/2, 1, 2. Oops, I did that wrong, didn't I? Try that again. 2, so it looks like this. And of course we have the asymptote at the end of that far left side. Okay, so if we're going to do a vertical stretch and a reflection, does it matter which order I do that in? Does it matter which order I do it in? No. No. So I can take this +1 and go to -1 first, and then what happens after I get to the -1? It's now going to get stretched 3 times the amount, so -1 would become -3. Very good. Or I could have went 1, get stretched to 3, then I reflect it, and I'll get -3. Same spot, right? Okay. At 1, 2, I would reflect it, so now it's at -2, and then what is it going to be when I vertically stretch it? -6. So 3, 4, 5, 6. There it is. Okay, let's do the half now. Half is kind of a little harder. Maybe, I don't know. Half gets reflected, so now it's at -1/2. And then what's 3 times that? Yeah, -1/2, so it'll go to there. And where is my asymptote? Did it get moved down or anything? Nope, it's still in the same spot. So it's going to go like that, right? Does everybody see? So this would be my y equals -3 bracket 2 to the power x. We good with that? I can raise it if you want. We're good? Okay, what's the domain? Same thing every single time, yes? What's my range? Very good. It's -infinity to 0, not including 0. Remember, we have to go least to greatest, yes? What's my x-intercept? None. What's my y-intercept? It's -3, yes? And my asymptote is still at y equals 0. And like I said, you can use the table of values to do it, but I think we're at the point where we can just transform the points. Okay, so what's wrong with D the way it's written here? Yeah, the B is not factored out. So first off, it's kind of written in a different order. Maybe I'll write it over here. 1 minus x. If I factor out a negative, what does the x become? Yeah, just positive x. And then what does the 1 become? -1. Does everybody see that that's the same as that? Yes? So I'm going to rewrite this as 2 to the power negative bracket x minus 1. Yes? Okay, who can describe what happened here? Reflection over the y-axis, yes, and it's a, oh yes, right one, sorry. Thank you. So, again, if you need to fill that out in, do so. But we're going to label our x and y axis. We have 0, 1, of course. At -1, it's at 1/2. At 1, it's at 2. And we have our nice curve. Yes? Okay, so that's my base graph. So let's do the reflections like it said. It's saying it's a reflection over the y-axis. Y-axis is here, right? So the 0, 1, when I reflect it, it becomes, it would be the same. Does anybody remember what that's called? Invariant point. Yeah, when you do a reflection, it doesn't move. However, we are going to go right one after that, so it actually isn't at the end or invariant point. Everybody good with that? Okay, so now here, the 1, 2 becomes to the -1, yeah, reflection. And then it gets moved over, so then it would be right there. Very good. And then the 1/2, the -1, 1/2 becomes +1, 1/2, and then right 1. Yes? So then it looks like that. So this is y equals 2 to the power 1 minus x. Everybody go with that? And there's something I forgot. I need to have my asymptote now on the other side, right? Okay, so my asymptote is still the same. What's my domain? Always and ever, -∞ to infinity. What is my range? Yeah, 0 to infinity. What's my x-intercept? None. And what's my y-intercept? Okay, so I think on yours, there's a missing negative on yours both here, I think, and a negative there. So just put that in. I don't know why it didn't print, so make sure we have the same thing. So who can tell me in order the description of the transformations that occurred here? Okay, I hear vertical stretch. Factor 1/2. Okay? Okay, well, hold on. A reflection over the x-axis. Very good. Then what? Right 4 down 2. Any difference of order that you could have here?
Vertical stretch, vertical compression factor 2.
You could write it that way. You could say vertical compression factor 2. You could actually move these in different order, right? You could do the reflection first, then the stretch. That would be okay. Same with here. You could switch the right 4 down 2 around. Could I move any of these up here before? No. Okay. So let's do the base graph again. Hopefully everybody has their base graph pretty down at this point. And that is, yes, -1/2, 0, 1, 1, 2, bada bing, bada boom. Here's our graph, yes. There's my asymptote. Y equals 2 to the power x. That's my base graph. So let's do the following reflections then. I'll give you a second to write that down. Okay, so sometimes it's easier to reflect than stretch, but I don't know. What do you think? You want to stretch first? Okay, so let's start at the nice one, the 0, 1 point. 0, 1 now becomes 1/2. Then it gets reflected to -1/2. Then you're going right. Okay, so let me do that again. It went to 1/2, then it went down to negative a half, then it's going right 4, 1, 2, 3, 4, and down 2. Now it's halfway between, so where am I going to end up? Negative 2.5, yeah. Okay. This next one, it's at a height of 2, the 1, 2 one, becomes 1, 1. Then we reflect, negative 1. Then right 4, 1, 2, 3, 4, down 2, 1, 2. Yes? I have too many points there.
It's almost like we should have more than negative direction.
Hold on. Why can't I get my eraser to be half the thing? It's this point and this point so far, just so you know. Okay, let's do this a half now. This is going to be craziness now. A half becomes a quarter, and then it gets reflected. Then it's going right 1, 2, 3, 4, down 2. Where's my new asymptote going to be?
Negative.
Yeah, y equals negative 2 because it went down. So, yes. Very good. Yes? You got it? So my asymptote is at y equals negative 2. It's hard because if we don't have the squares behind it, when you're doing your homework and you're doing graphing, I highly suggest that on my OneNote to print the graphs that I provide that looks like this so that you can graph properly. This is too hard when you don't see the back part, right? Or grid paper.